Hi students, have a nice day. In this section, we will continue the rules for naming. In the last section, we have seen that the word roots and suffixes. So in this section, we discuss prefixes and how to write the name of an organic compound. Okay, what are prefixes? Pre means before. So prefixes are writing before the word roots. Okay, prefixes are used to write right before the word root. And to represent the substituents. Prefixes represent the substituents. What are substituents? The atom or group of atoms other than the hydrogen. So in the organic molecule, sometimes the atoms or group of atoms other than the hydrogen is bonded to carbon atom. These atoms or group of atoms are called as substituents. So prefixes we write before the word root and these represent the substituents. Okay, prefixes are also classified two types, primary prefix and a secondary prefix. So naming rules we continue. It is third one, 3. Prefixes. First one is primary prefix. Primary prefixes or primary prefix. Primary prefix, whether the molecule is cyclic or open chain. Okay, so cyclo is used as a primary prefix for cyclic compounds. Cyclo is used for cyclic molecule or cyclic compound. Okay, first one. It is the bond line structure for cyclopropene. CH2, 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 CH. Okay. So 3 CH2 form a ring-like structure is called cyclopropane. Remember that cyclo is a prefix. Prop is the word root. Okay, prop is the word root. The molecule is saturated, single bond between the carbon atom. So ANE and the molecule is cyclo. So it is right before the word root. After the word root, we call suffixes. ANE is a suffix, you know that. So cyclopropane. Similarly, cyclohexane. Okay, CH2, 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 CH2. This is simple bond line structure. It is condensed structure for a cyclohexane. So cyclic compound we use cyclo as a prefix. 6 carbon atoms, so we use hex as a word root and the molecule is saturated and ANE. What is the name of this molecule? Cyclohexane. Okay, primary suffix is very simple. Sorry, primary prefix is very simple. Cyclo is used for cyclic compound. Cyclopropane, cyclobutane, cyclohexane, cycloheptane, like that. Okay, hope you understand the prefix cyclo. And second is secondary prefixes. Okay, secondary prefixes. Secondary prefix represent the substituent. In some cases, the functional group or the alkyl group. Okay, some functional groups and alkyl groups are prefixed in the naming of an organic molecule. As we know that functional groups are suffixes. In some cases, if the molecule containing more than one functional group or the functional groups such as halogens, nitro compounds, all these are always prefixed. Halogens are, even though halogens are functional group, they are prefixed. Nitro compounds, NO2 group. Nitro group is a functional group, but the word nitro is prefixes. Okay, let's discuss secondary prefix. Secondary prefixes, which represent the substituents. Substituents are maybe functional group or alkyl group. Okay, alkyl groups or some functional groups are secondary prefixes. Okay, let's make a column to understand the concept. Substituents. Secondary prefix. Secondary prefixes. First one is halogens. We use halo. Generally, halogens, halo. For example, if fluorine comes, fluorine, we use fluoro. Chlorine comes, we use, not chloride, chlorine. Chlorine comes, we use chloro. What about bromine, bromo. Br comes, bromine comes, it is bromo. Iodine, when the iodine is present in the molecule, we write iodo. Okay, are you clear? Yes. So halogens, they are used as a prefixes, secondary prefixes. Then next, when NO2 group, nitro group comes, nitro itself has a secondary prefixes, nitro group. Then I just erase this. The next is sometime alcohol group or alcohol functional group comes as substituent. Let's continue. OH group, OH, alcohol. When alcohol comes as a principal functional group or functional group, it is all. It is used as a suffix. But when the alcohol group comes as a substituent, we use hydroxy. Very clear? Then NH2 group, amine group. When amine group comes as a substituent, when it is functional group, it is amine itself. Amino. The prefix is used as a amino. Very clear? When cyanide group comes, CN. When cyanide as a principal functional group, it is nitrile. Nitrile, nitrile. But when it comes as a substituent, it is cyano. Okay, cyano. Next is aldehyde group. Sometimes aldehyde groups comes as a prefix, a substituent. Okay, at that time we use formyl, or in some cases we use oxo. Formyl is the secondary prefixes when CHO group. when CHO group comes as a substituent. Next is ketones. Okay, I just erase this. Next, keto group comes as a substituent. When keto groups comes as a functional group, we use ON. Okay, but when it comes as a substituent, we use OXO. Okay, OXO we used as a secondary prefixes. Are you clear? Yes. Then another one is alkyl groups. When alkyl group comes as a substituent, alkyl groups. For example, CH3, or it is written as Me. Okay, methyl group. Methyl itself. When CH2CH3, or in some examples or textbook or in some questions it is ET for ethyl. We use prefix as ethyl. Also it can be written as C2H5 or CH3CH2. Okay. Various representation for ethyl group. CH2CH3 or CH3CH2. Or in some textbook it is ET. ET means ethyl. Then condensed formula C2H5. Okay, C2H5, it is also called ethyl. Then when CH3 comes, or C3H7 or NPR, it is written as N-propyl. The N denotes normal straight chain. Okay, the N denotes normal or straight chain. Remember that. Okay, listen, very important concepts, simple. But if you don't understand this, you can difficult to follow. You feel difficulty to write the naming of organic compounds. Okay, so please understand the concept. CH3 means straight chain, normal chain. That's why we use the letter N. So what this small n denotes? It is normal. So N-propyl means normal propyl. Okay, straight chain. Or it is C3H7 or NPR. Okay, NPR. This is simple. Then we move to the another example. It's isomer. Okay, it's isomer. CH3. If the group comes like this, it is isopropyl group. Isopropyl group. Sometimes it is written as CH3 twice CH. So whenever you see CH3 or CH3 twice, 2 times CH3 to a carbon atom, it is called isopropyl group. Okay, isopropyl group. Another is CH3, CH2. Okay, so very important thing, you please listen. How many carbon atoms in this species or in this alkyl group? there are 4 carbon atoms. So, and also it is a straight chain. Okay, so it is N-butyl group. N-butyl group. A very important N-butyl group. Then, or it can be written as CH3, CH2 3 times. 1, 2, 3. 3 CH2 is attached to the CH3 group. It is also N-butyl group. Also it is represented N-but. N-but. Another is its isomer. CH3. This CH3 comes here and one more hydrogen replaced. So CH3. CH2. Okay. It is the isomer of this alkyl group and is isobutyl. Okay, isobutyl group. You please understand that. This is N-butyl because of straight chain, normal chain. This is its isomer. Okay, isomer of this butyl group is called a isobutyl group. Another one, CH3, CH2, CH, CH3 link. Okay, this link comes in the second carbon atom. So, this carbon is secondary, you know that. Okay, you know that this is primary, secondary, primary. In this case, it is primary, also this one is primary. To distinguish the carbon atom in the butyl group, we use sec-butyl. Okay, sec-butyl. What it means? The butyl group is secondary. Once again, here it is a straight chain, 4 carbon atoms. The carbon which is linked to the parent chain is primary and is called N-butyl. N-butyl means normal butyl. Okay? Yes. Then here the linked carbon itself primary. Both case linked carbon is primary. But this is the isomer of the N-butyl group. And we use isobutyl as a prefixes. Isobutyl as a prefixes. And in this case, the link is changed. The link through the second carbon atom. And the carbon is a secondary carbon. That's why we use secondary butyl. Okay, secondary butyl. Another one, CH3, CH3. Link is through this carbon atom. Okay, link is through this carbon atom. Or it can be written as CH3 3 times C. Okay, look at this carbon. 3 methyl groups are attached to one carbon atom. That's why it is tertiary. So this carbon is tertiary and we write tert. Tert for tertiary. Tert butyl. So what is the difference between secondary and tertiary butyl? In secondary butyl group, the carbon atom, the secondary carbon atom linked to the parent chain. And in the case of this molecule, tertiary butyl, the tertiary carbon atom is bonded to the parent chain. Okay, you get the difference? Yes. So these are some important alkyl groups. Similarly, pentyl group, isopentyl group, neopentyl groups. Okay. In pentyl, I just write in pentyl CH3, CH2 4 times. It is N-pentyl. It is N-pentyl group. Then CH3, CH, 3, CH2, CH2. It is isopentyl. Then CH3, 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 CH2. The link is through this one. Okay, it is neopentyl. Neopentyl. Okay, these are the different alkyl groups used as a secondary prefixes. Okay, a very important thing. Prefixes, primary prefixes and secondary prefixes. Then we try to write. Then we learn to how to write the name of an organic compound. Okay, we have a formula. Okay, a simple formula. If the molecule have substituents, we write it as a prefixes. Okay, we have a simple formula. Secondary prefix plus primary prefix plus word root or root word. Okay, word roots plus primary suffix plus secondary suffix. And a molecule should contain word root and primary suffix. Others are optional. If there is no cyclic molecule, okay, we don't use cyclo. If there is no substituent, we don't use secondary prefix. If there is no functional group, we don't use secondary suffix. So, these are optional. Secondary prefix, primary prefix and secondary suffix are optional. If the molecule contains, okay, you write secondary prefixes, primary prefixes and secondary suffix. But a molecule should have word root as well as primary suffix. Okay, let's take an example. CH4. A simple example. CH4. CH4, the number of carbon atom is 1. So, what is the word root? Which is meth. Then, no other functional group, no substituents. So, we add whether the molecule is saturated or unsaturated. So, here only word root and primary suffix. What is the name of the molecule? Methane. Okay, methane. And another is CH3, CH2, CH3. How many carbon atoms are in the molecule? 3. So, word root is prop. Then all the bonds are single bonds. Then saturated molecule Ne. No other substituents, no functional group. So, only word root and the primary suffix. Okay, so a very important thing, a organic molecule should contain word root and primary suffix. Secondary prefix, primary prefix and secondary suffix are optional. Okay, optional thing. Then another thing, when we write to primary suffix and a secondary suffix, okay, when we join the primary suffix and the secondary suffix, There is one important thing. When we join the primary suffix and the secondary suffix, if the secondary suffix is started with a vowel, A, E, I, O, U. Okay, secondary suffix started with a E, I, O, U vowels. E of the primary suffix should be dropped. Okay, once again, I will explain with an example. It is easy to understand. While you writing, okay, you keep it in your mind. Secondary prefix, primary prefix, word root, primary suffix, secondary suffixes. Okay, when we are writing the primary suffix and the secondary suffixes, some rules are there. Okay, let's explain with an example. For example, CH3, CH2, OH. How many carbon atoms are there? 2 carbon atoms. So, ethyl. When 2 carbon atom comes, the word root is ethyl. So, eth. Sorry, not ethyl, eth. 2 carbon atoms, and it is an alkyl group. It is ethyl. Eth. Then the bond between the carbon is a single bond. ANE. Okay, saturated AN. And there is a functional group. Okay, there is a functional group, alcoholic functional group. Suffix is all. Then how you have to write the name? Ethanol. Ethanol. So E is dropped, E is removed because it is O is a vowel. Okay, so when we combine, when we join the primary suffix and secondary suffix, if the secondary suffix started with or starting with a vowel, E of the primary suffix is dropped or E of the primary suffix removed. This is a very simple example. Another one. CH2, NH2. 3 carbon atoms, so prop. Single bond between the carbon atom A and E. And the functional group is amine. Okay, the functional group is amine. Then how we write the name? Propan amine. The correct name we will discuss the rules later. Propan 1 amine. Because the carbon atom is numbered and the NH2 group is attached to the first carbon atom. So here you listen, E is dropped, E is removed because the secondary suffix started with the vowel A. Okay, but when the secondary suffix started with a consonant, the E must be retained, the E must be there. Okay, let's take another example. CH2OH, CH2OH. Okay, so 2 carbon atom, H. Single bond between the carbon atom, so ANE. 2 alcohol groups are there. Okay, 2 OH groups in the same molecule. So diol. 1 alcohol, you just write ol, OL. 2 alcohol groups in the molecule. So diol. Okay, then ethane. E not dropped. E should be there. E must be retained. And the carbon atom is numbered as 1, 2. In the reverse order it is same 1, 2. Okay. In the reverse order it is 1, 2. So no problem. 1, 2 diol. Okay, 1, 2 diol. So E the E is not removed. E must be retained. Okay, the E must be retained because it started with a consonant. So let's conclude. When a molecule is named, we have word root, suffixes and prefixes. Okay, word root and primary suffix is compulsory. The others are optional. Then when we combine, when we join the primary suffix and the secondary suffixes, when the secondary suffix starting with the vowels A, E, I, O, U, the E of the primary suffix is dropped. Okay? When the secondary suffix started with a consonant, E must not be dropped. E should be retained. Okay? So these are the important rules. Many rules are following. So up to this, you study. Next day, next section we will discuss naming of hydrocarbons. Thank you.